All right, let's dive right into this explainer. If you've ever thought about running large language models locally, right on your own machine, I bet you've pictured exactly what I'm picturing. A massive, glowing, liquid-cooled computer tower. The kind stuffed with RGB lighting, enough fans to sound like a literal jet engine, and a dedicated GPU that makes your monthly power bill look like a car payment. The tech community just has this deep-seated obsession with flagship hardware, right? Especially with the notorious VRAM hunger of modern AI. But today, we're digging into a really fascinating XDA article by tech writer Yash Patel. And honestly, it completely challenges the whole conventional wisdom about self-hosting AI. We're going to look at why building a local AI workstation is actually a lot more accessible and, frankly, completely different than what the community usually assumes.
So, most of us enthusiasts just assume that running local LLMs requires a massive, power-hungry GPU. I mean, it's basically taken as gospel on tech forums. If you want to spin up Llama 3 or Mistral, you obviously need a beefy card. But Yash's experience really forces us to step back and ask, are we literally using a sledgehammer to crack a nut here? We often think we need a 300-watt dedicated graphics card just to run a relatively simple 7 or 8 billion parameter model. And in doing that, we totally ignore the massive power draw and the space heater levels of heat for a task that might take less than a single second to compute. So are we wildly over-engineering our setups for daily tasks that don't actually need all that raw compute? Well, let's find out.
Here's the game plan for today. First, we'll bust the big GPU myth. Then, we'll look at how everyday AI actually runs on integrated graphics, pinpoint exactly when you do need that RTX power, and finally, talk about prioritizing workflow over pure horsepower.
Let's jump straight into Section 1, the big GPU myth. Okay, the contrast between expectation and reality here is just wild. When Yash started testing local LLMs, he did exactly what any hardware enthusiast would do. He assumed his desktop's mighty RTX 5070 was going to be his daily workhorse. He was ready to push that silicon to its absolute limit. But as he actually started weaving AI into his daily routine, that incredibly expensive GPU just sat there, completely idle. Why? It all comes down to psychological friction. Booting up a heavy desktop rig, waiting for it to load, forcing yourself to sit at a specific desk, that is a huge barrier to entry. If you literally just have a quick 10-second question for an AI, you aren't going to go through the whole ritual of firing up a massive workstation. He found he wasn't even touching his desktop for his most common AI needs.
And that unexpected reality leads us seamlessly into Section 2, where a really surprising piece of hardware steps up: everyday AI on iGPUs.
Think about what we actually use AI for on a daily basis. Rewriting a couple of awkward sentences, asking it to explain a confusing concept, summarizing a few meeting notes, or just brainstorming ideas. When you look at the technical scale of those tasks, the context window is incredibly small. You're not feeding the model a massive novel, right? You're feeding it a paragraph. For those super short bursts, sending a prompt to a high-end GPU means it spins up, executes the whole thing in milliseconds, and goes instantly back to sleep. It barely even wakes up the RTX 570 before the job is completely done. It is absolute, complete overkill for everyday use.
So what did Yash actually end up using? Just 16 gigabytes of system RAM. Specifically, he was relying on a pretty modest Ryzen 7 5825U laptop with integrated Radeon graphics and just 16 gigs of memory. Now, to a lot of us, an iGPU sounds laughable for AI, but here's the massive architectural advantage we always forget about. iGPUs share system memory. If you're running a quantized 8 billion parameter model through LM Studio, you only need about 5 or 6 gigs of RAM to hold it. Because that Ryzen iGPU can dynamically tap into the 16 gigs of system RAM, it elegantly bypasses the strict VRAM bottlenecks that usually choke out smaller dedicated GPUs. This laptop handled everything beautifully, all while regular apps were open without freezing up at all. Now, when you put that RTX 5070 desktop head-to-head with the Ryzen laptop, the true equalizer isn't the silicon, it's human reading speed. Sure, the desktop might spit out a blistering 60 tokens per second, and the laptop maybe pushes 12. But if you're just generating a 3-sentence summary, the laptop finishes typing it out right as you finish reading the very first sentence. The desktop speed is technically superior on a benchmark chart, sure, but practically, it's totally invisible for this kind of workflow. Plus, the laptop gives you ultimate flexibility. You can use it on the couch, at a cafe, in a meeting, all while the desktop's raw power remains completely untapped and honestly unnecessary.
This brings us to Yash's big epiphany. An LLM workload doesn't automatically become demanding just because it's running locally. We've been so conditioned to think local AI equals melted hardware, but processing an AI workload locally scales purely with the task. A simple task, means simple hardware demands. And let's talk about power efficiency for a second. This modest laptop is handling these tasks while pulling maybe 15 to 20 watts from the wall. Meanwhile, a desktop GPU might idle higher than that just to keep your monitors turned on. The efficiency of actually matching your hardware to your workload is just undeniable.
But look, we can't pretend laptops are magic and can do everything. There's definitely a time and place for horsepower, which brings us to Section 3, when you need RTX.
When you break down these ideal workloads side by side, the performance gap becomes pretty impossible to ignore for heavier tasks. The absolute second you transition from short daily tasks to actual heavy lifting, that RTX 5070 becomes a total necessity. The iGPU is fantastic for flexible, low-power convenience, but what if you're coding and need massive 32K context windows to feed in entire software repositories? Yeah, that laptop's gonna crash. If you want to spin up massive 70 billion parameter models or do intensive local image generation with stable diffusion, the integrated graphics just cannot cope. For those scenarios, the dedicated RTX card gives you the raw speed required for smooth, uninterrupted experimentation.
Because here is the harsh reality of relying on modest hardware for complex workloads, the waiting time quickly becomes a devastating bottleneck. It stops being about whether the laptop can generate an answer and starts being about how long you're forced to sit there waiting for it. And psychologically, that's a killer. Imagine you're deeply focused, debugging complex code, testing AI outputs iteratively, and you have to wait 45 seconds for every single response. That completely shatters your flow state. Your mind wanders. That speed of interaction, that ability to stay locked in, that is exactly what you are paying for when you shell out for an RTX 5070.
So how do we successfully balance the quiet, portable convenience of an iGPU with the roaring power of a dedicated graphics card? That brings us to our final section, workflow over horsepower.
Yash realized that instead of forcing one single machine to do absolutely everything, the smart play is to build a synergistic setup. Step 1. Pick your model first. What are you actually trying to achieve today? Just summarizing a quick email, or are you coding a whole app? Step 2. Choose the hardware that fits that model. Email, open the laptop. Coding, fire up the desktop. And step 3, keep the software environment incredibly simple. Tools like LM Studio are awesome for this because they let you easily dictate how many layers of a model to offload to the GPU versus the CPU. Just find a configuration that is good enough for your chosen hardware and lock it in. Seriously, don't spend hours tweaking VRAM settings chasing a 5% benchmark boost when you could actually be getting work done.
The biggest takeaway from this whole experiment isn't just that an iGPU can run AI. It's realizing how rarely we actually need our most powerful hardware for the things we do every single day. By intelligently matching the tool to the task, you save power, you save a ton of frustration, and you end up integrating AI way more naturally into your life. So think back to that giant glowing PC tower we talked about at the beginning. Look at your own setup right now. Are you optimizing your local AI for your actual daily workflow, or are you just building a very expensive sledgehammer to crack a nut? Something to think about. Thanks for joining me for this explainer, and I'll catch you in the next one.